will be on the screen. Okay. Hello, everyone. Hi, welcome. Here I'm with Irina to start our beautiful day of AVP.NET Conference 2024, day 2 of talks. And thanks everyone for joining us, no matter you are from yesterday, the workshop, or you are just new friends for today. First, I'd like to share some surprising news with you, which is the raffles. Wait a second. Oh, I think people cannot share. Okay. Sorry guys, I think I met some problem with the.
I think you should stop and reshare the screen.
Yeah, I think I have some problem somehow to share my screen, but it's okay. I can introduce you about our raffles this year. So we're gonna have 19 winners for this year, thanks to our sponsors. So I'm gonna quick to tell you what we got for this year. So first we will have 5 AVP personal license plus ebooks of .NET related. And we also will have 6 IDE coupons from JetBrains. So thanks to JetBrains. Also, we will have 2 copies and 5 ebooks from Pact, thanks to our sponsor Pact. Also, we have 5 Ragu React for AVP commercial license, which value like $250 from Y Technology, our gold sponsor. And also, please don't forget to go Mailtrap, our bronze sponsor. You can go their exhibitor and check the link of a fun quiz, and then you can win like $100 valued Amazon gift card as well. And we will announce all the winners at the very beginning of the day at the raffles and closing session. Okay, that's all for my part. Now welcome to our beautiful speaker, Irina, with his very insightful presentation. Okay, here you go.
Thank you for your introduction. So I'm very glad to be here. Thank you for inviting me and to give me the stage for presenting gRPC. gRPC has been one of my favorite topics lately because it's simply it's another tool in our tool belt as developers. So let's see what gRPC has to offer. So first, my name is Irina. I'm from Romania. I'm a software architect. I blog from time to time, and I'm Microsoft MVP for developer technologies. And if you have questions or curiosities for this talk, you can DM me on Twitter. You can find me there at Irina_Scurtu. So we can chat. Of course, questions are welcomed. You have that the application for the conference where you can ask questions. I will gladly answer them. So another thing, if you have friends that want to transition to web API development with .NET, this might be the book for them. So let's have a look. Okay, so first, I would like to remember the good old times because we cannot talk about shiny technologies, nice architectures without talking about the monolith. To be fair, if we were on a real environment, I would ask you to raise your hand if you ever worked and loved working with monoliths, and I would be the first one that raises my hand. To be fair, I really enjoyed working with monoliths because the life was very simple to me as a developer. Everything was there. I mean, you had a single code base for everything. You didn't care about orchestrating, integrating with flying components in the distributed system. Everything was one piece of code. And if you wanted to, I don't know, have get your dependencies were in the code. You went there, instantiated a class, use it, and so on. And to be fair, I remember the time when we had big solutions when we had to think twice before building the solution, because it took so much that we could go outside and grab a coffee. So the deal with the monoliths, becoming serious now, is that it's easy to start with. You have a single code base, usually written in one single language. But the cons about working with monoliths is that they are hard to scale. I mean, you can scale them, but it's all or nothing. So either the deploy works and the app works, or not, and you are forced to do rollbacks and so on. The idea with the monoliths is that when you scale, you have to scale everything. And that is not necessarily proportionate in terms of costs, in terms of money. So you might have system components in your system that are super small or super big, but not used by the users. And you are forced to scale those components too. So we basically started with this kind of architectures. We had front end and back end in the same space, in the same monolith. I remember working with ASP web forms. So ASP web forms, anyone here? Then we moved on to MVC, which promoted a bigger separation of concerns, gave us boundaries for things that are concerning to presentation and so on. And then we started to realize that, hey, we can split the things. We can have the backends, we can have the front-end apps written in whatever JS. And we started to develop REST APIs, okay? But we all know the future is distributed. And now we might have front-ends that communicate with backends or with several backends. And those backends might communicate with other APIs behind the scenes without us knowing. And this way we get very disparate components. So those components, we realize that those components need to communicate with each other. We have these wannabe polyglot environments. So we might have an app that is written in .NET that needs to take something from a Go app or a Node.js app. We end up with the spaghetti code, okay? But this spaghetti code has a common language, REST. And I would ask you, to be honest, who here implemented REST APIs? All of you. So how many of you really chose to implement all the guiding principles from REST? And I will lower my hand now. Because we realize REST is good for public-facing APIs that are meant to be consumed by browsers usually. But we kind of strip those things that we do not care about, like HateOIS, hypermedia, stuff like that. We use to from them only those things that are interesting to us. Verbs. We at least now we use separate verbs to create resources, to update resources, and so on. So what's wrong with REST? In essence, nothing is wrong with REST, but when you use REST as a server-to-server communication mechanism, and you have APIs that calls other APIs, and that communication is done over HTTP. So you have a service that calls a downstream API to get data or to send data. We might realize we have other tools at our disposal that we might use, and they're better suited for those scenarios. So there are other technologies out there, and one of those technologies, it's called RPC. RPC has been around since the 70s as a concept when people discovered distributed systems. So when they discovered and they started to write distributed systems, they realized they can split the monolith into smaller chunks that run on their own machines. And after that, they realized that they don't like that. So they invented a piece of technology called remote procedure calls to make those components that are distributed in different machines behave like as if they are on the same machine. So they're putting it back together now. So RPC, let's have a look at some code. So we have here an order. It calls a sales bounded context, create order, and then we process the payment for that order. And based on the successfulness of that payment or not, we arrange the shipping or not. Okay. If we look at this code, to us as developers, this is very programmatic. It has a call method look and feel. We call the methods, we get results, and we act upon the results that we get. But what really happens is, for example, when we call the process payment for that specific order, we get a call over the network. And the deal with network calls is they're unpredictable and slow. And hence, and since we're not aware that we're doing network calls because we're basically calling methods, we're not consciously thinking that we do network requests, as we would do, for example, what if we would have an HTTP client where we instantiate the client, and then we do an HTTP request to get data or to send data, and we process the response, we look at the status code, and so on. With RPC, things are very call a method, get some data, send some data, and that's it. So RPC as a whole will make the code look local, even though that call is made over the network. So it's prone to errors, and its main goal is to make network communication transparent. Making it transparent means that we kind of use and make calls, but we do not care that the network is there, it's transparent, we see through it. So people started to think, what if having a distributed system and get all the perks from that, but make it behave like a monolith? That would be cool, right? Putting the distributed system all together. Okay, so enough with the history. How about gRPC? Because here we're to talk about .NET. gRPC started in 2001 as being a Google internal project. And if we fast forward a few more years, that has been open sourced, and we got it in .NET in 2019. And since then, a lot of things around gRPC had been improved and established. Now the tooling is better. We have a nice experience in Visual Studio even with gRPC. In 2019, that wasn't such a nice experience. So gRPC is contract-based. This means that we will only have a contract between the parties that need to communicate with each other, and we will have no more code references. So whenever we're using gRPC, we won't have a NuGet shared package or a package distribution through NuGet. It uses HTTP2 as a protocol, which makes it inherently faster. And it also has a serialization, which is binary, and it's called protobuf, which in the end ends up having a smaller payload, which makes it more performant for us. It is available in many languages, and it does code generation out of the box. It means it will allow us to have a Node.js app talk with a .NET app through this contract called protocol buffers. So if we were to compare the client and the server communication patterns that we are familiar with from HTTP APIs, now in between our client, which in itself it's a server, we will have this file called proto. Proto file is a special file written in a special syntax named protobuf, which is neither Java nor C# nor other language. It's called protobuf. It's basically a specification language in which we go and specify what we expose in terms of services. So first of all, to write such a file, we have to specify the syntax, and then we have to specify the namespaces that we want to generate after that. And then we start defining our services. The services contain operations that we want exposed to the outside world. In our case, we have service called Fibo, which exposes an RPC method or operation named compute Fibonacci that has an input of type requested number and returns a Fibonacci result type. Basically, if you ever worked with SOAP and you remember that WSDL page where you've seen all the operations exposed, this is pretty much a replacement for that in a way. So further down the line, we have to define the types. In protocol buffers, the types represent will be transformed to C# classes. Okay, so we have a message which will be a class. It's a named requested number, and inside it has a property named number of type int32, and it has here something that looks to be an assignment, but it's not. Equals 1, it's actually the order in the binary string of this specific property. Since these will be serialized to binary, we have to order and to know where the binary string ends or starts. So basically, this requested number will be transformed into a class that has a property of type int, named number, and that's it. Okay, so our types here will get transformed to C# types that we will use inside our application. So once we define this, we can take this file and share it across our system, and whoever interfaces this class will be able to call the service that actually has the logic, the implementation logic for everything that we specify here. So what's so special about gRPC, besides the fact that, is performant, is new, and we have some other things to learn about. So one of the powers of gRPC resides in method types or modes. These are 4 of them. One of them is unary, server streaming, client streaming, and bidirectional streaming. What happens is we have 4 ways of getting and sending data over a single TCP connection without us needing to open connection. So you have one single connection and you can do all 4 of them. And we will have a look at them just now. So gRPC unary method is similar to what we know from request response traditional way. In unary, the client needs to initiate a communication channel to the server, and the server will respond back. To define such a method, it's super simple. We will say that we have the name of the method, we have a requested number that returns an output. So basically, in terms of parameters, for these methods that we expose, we have an input and we also have an output. That's why it's called unary. We have 1-to-1. Another thing that I really feel the need of specifying is that we cannot have no parameters here. So even though these are methods, and we know that we can have methods that take no parameters, with gRPC, we have to specify something. Even though that something might be empty, but we have to specify a type. The next one is gRPC server streaming. Server streaming works pretty much in a similar way, but the client still needs to open up the communication channel. Even though the server is streaming, the client will open a communication channel. So this is different than Signaler does, where it pushes things without the clients ever wanting it. Okay, so the server streaming is pretty much similar to unary. It's done over the single TCP connection, but the server will send several chunks of data over that connection. Okay, so get one thing in, and we will return a stream of results. Yeah, so basically we have one thing as a parameter, but several things as an output. So it would be like one to many. gRPC client streaming works in reverse. The client will open up a communication channel and it will send several pieces of data, and the server will process those and send only one response back. To identify such an operation, we simply add the keyword stream to the part that supposedly has many chunks of data. So many ins and one single out. Think about scenarios where, I don't know, you have to upload data in chunks, collect data from different sensor, sensors or stuff like that. It's very useful. The next one, bidirectional streaming, basically combines the previous two ways. The client opens a communication channel, sends several things in, and then the server sends several things out. To identify such an operation, you will have the keyword stream to the part that supposedly sends several things in, and stream to the next part. So we have many ins and we have many outs, many to many in a way. So enough with the enough with this. Let's see some code. Okay, so you should be able to see Visual Studio, and in here you'll have access to the source code by the end of the talk. So don't worry, you'll be able to run it by yourself. So what I want to show you here is that we have a server, and then we have 4 clients: bidirectional, client streaming, unary, and server streaming. So let's have a look at what a gRPC service means. So you will be able to find that service by simply adding a new project, and you'll find your template. You'll be able to select gRPC, and you'll have a template here. If you click next and you fill all the gaps, then you'll end up with a project that looks like this. It has a few things that we're familiar with: program CS, app settings.json, and pretty much that's it. This gRPC service is nothing more than a console app written in .NET that has some specific things. For example, it has protos, in which it has a similar proto file as you've seen in my presentation. So it has a template that exposes a service named greeter. It exposes, which in turn exposes an operation named say hello that has a hello request in and returns a hello reply. So these are 2 types, okay? So this is the specification basically. If you look here, we will have a folder called services, in which you find one single service exposed. And if we open that up, you'll see that the greeter service extends some class called greeter base, which actually implements that method that we exposed. I'm going to try to move this a bit. Okay, so we exposed one operation called say hello, and we give an implementation for it by basically extending a base class. Remember that I told you that gRPC does code generation for us? Well, let's see what it generates for us. I'm gonna dig into this greeter base class that is generated by the Proto-C compiler, and you'll see that it also has some warnings generated by the protocol buffer compiler, do not edit, and it has some funky looking code. This funky looking code is generated based on what we specified in the proto file, and it gives us the possibility of overriding whatever the methods are that we defined in the protocol buffer file. You'll be able to find those files by simply clicking in Visual Studio, go into debug, protos, and you'll see them in here: grid.cs, grid gRPC.cs. And those are the files that you need. These files contain the logic that we exposed, and also some clients that I will show you soon enough. I'm gonna close this. Okay, so once you expose this, you'll be able to basically run this and let other components of your distributed system connect to it and get and send data, as you would do with the normal HTTP API. And with this being done, in program CS, you'll see that there's nothing fancy happening. We simply have the middleware for add gRPC, and then we map the service that gives the actual implementation for what is specified in the proto files. Okay, so this is the demo example. Let's look at our server, and you'll see that is that type of project. It has here the grid proto, but this time I have 4 methods implemented, 4 methods defined in order to make them visible. we have a message that is called request. I specially named it request to have it as a comparison with the request response from HTTP. Response has a message, content value is the message here. And we have an implementation. As you see, greeter service is simply a class. You can inject everything that you need to inject, repository, other services, and so on. It's nothing complicated. And then you come here and you simply go and overwrite what's in the greeter base generated class. So you give an implementation for say hello. You'll see that it receives a request, it does something, and it returns a reply or a response. What I also want you to notice is that each method, even though we specify it has this as a parameter, it will always have this server call context as a second or the third parameter. The server call context gives us access to things like the current HTTP context that we're familiar from MVC or web forms or any other programming models around .NET. And from that get HTTP context, we are allowed to extract things like user, credentials, claims, or whatever we put in there. So once we have the server here, I'm going to start the console app with the server running. I'm going to try to find it. And supposedly it will be here. I'm going to clean it. It's easier to follow. So if we want to make calls, we will be able to, we need to have the server running. So we'll have .NET run. And as soon as this it's up and running, you'll see that it listens on a specific port, 5000, and pretty much that's it. And now we're able to do requests. So in order to do requests, we need some clients. And the easiest way of testing the gRPC out is to go here and look at one client. The first client that I want to have a look at is the Unary, which is nothing more than a console app that has a few packages installed, Google Protobuf and gRPC Net Client and Net Client Factory. gRPC tools is also something that you might want installed, but let's have a look at one thing. Once you create a console project, if you want to be a consumer for a gRPC service, you have one option. You can go here under the dependency node, under the project, right click and click add connected service. And under the connected service, you'll see this wizard here, which I fairly enjoy working with. And you click the plus sign, and then you'll have the option of specifying which type of service reference do you want. You'll click gRPC, you'll click next, and from there you'll be prompted to browse and find the protocol buffer file. Remember that I told you that the gRPC protocol buffer file is a contract and you'll have no more code references. So as soon as you go and dig in and find the protocol buffer file that you need, I'm going to let you hear. So basically my Unary project, protos, you'll see here something that is rather funky. It's like a virtual folder inside the project. Basically, this grid proto is nothing more than this protocol file that sits on the server side. That's the only thing that these two projects have in common, the protocol buffer file. And once we have that, I told you that we have no code references. And let's have a look here. Our only dependencies are, if we can call it dependency, protocol buffer file, which is that one here. But in terms of add reference, add project reference, we won't have such a thing. The deal is if we edit the Unary, the project file, you'll see a small thing here, item group, protobuf include, this is the path to my proto file, which is on the server bit here. And you see that here acts like gRPC services client, and then it has this link with proto. This is the one that does this like folder looking arrow, virtual folder look and feel. You can edit and add this by hand if you want, or you can use that wizard that I showed you that basically does the same thing. Inserts this. Okay, so now that we have this thing in common, we will be able to go in program CS and say, hey, I want to create a channel. gRPC uses channels, which are like virtual pipes to the server. And that channel is opened to the server address. Since you know which is the server address, I hard-coded it in here. I don't advise you to do this in practice. Then you'll have to create a channel. A client, it's done as you would do an HTTP client. So you have greeter client, and you pass in the channel that knows where the server is and can get some additional parameters. So basically, this greeter client is something that is generated by us, for us. We didn't write it, but it's there for us to use. And when you create a client, you have here the request object. I told you that request message gets transformed to a request class, which has the property of our thingy that we declared there. So what do is simply go there and say client, and we will get prompted which are the options that our protocol buffer exposes, okay? So we say that we want to say hello, pass in the request, and everything is done. Now we also have the option to send some things that are dependent to the current call, like call credential, add headers, which in turn act like key value pairs that can send with the gRPC request itself. So let's see how this looks. So I have a console app that waits for me to make requests, so gRPC server. And on the right-hand side, I have the console app for the Unary. I'm going to try to maximize it here. And I'm going to do a .NET run. And as soon as this runs, you see some things moving. So I'm sending hello FII, hello back with this from the local host 5000 server. But let's see what happens on the server side. So on the server side, the server started receiving a call of type Unary to this specific method, say hello. It executes that, and you'll see that the request finished with some parameters. The parameters is HTTP2 as the protocol. It's a post request. It's done over this like path, but it's not the path, it's the actual method that we have running on the server. And we have 200 status code at the HTTP level. And then we have application gRPC MIME type, and it took this amount of time. Okay, so basically we do a post request every single time. Even though we get things, we kind of do a post request. Let's have a look at the second type. So we have the client streaming. The server is still up and running, so we'll be able to do .NET run to see how on the server side, we're sending an I in a loop, and we're increasing that I in that loop. So many things in from the client and one single thing out from the server side, which is the last value that the server sent. If we look at the code, you'll see here the client streaming. So basically, we open up the channel, we obtain a client passing in the channel, and then in a for loop that goes to this value, we're sending and writing async in the request stream. Each time a new type of request, a new instance of the request type. And then we await from the call to be completed, and we write to the console line the last thing that the server received. On the server streaming bit, things work in reverse. So we have an address, we have a client, and we will wait for the responses that come from the server. So we await the responses because the server bit is the one that goes in a loop and sends things. So we will see that in the services on the server string bit, which it does a for loop, goes to this value, sends a new response message type, and then writes it into the response stream. Okay, it works in a similar way. And if we look at the server streaming console, you'll see here too that it's an HTTP2, it's a post request, and its client streaming operation called. Here I'm going to do a .NET run again. And you'll see how the server sends things to the client in here. It receives one thing, but it sends several hellos back. The bidirectional one is pretty much combining the previous two. I'm going to clear this out, and I'm going to do a .NET run. And you see it's sending, and you see it's receiving. These are ordered, but these are ordered here because this is how they go. In terms of code, bidirectional is fairly easy. From the client side, have a channel, have a client, and await and read from the response stream, and then send requests. And the services bit, bidirectional, it's pretty much the same. As long as you have things from the request stream, write those back as a reply, okay? You can have any logic that you want in here, but I thought this is easier to understand. Okay, so now back to the slides. There are a few things that gRPC should do, and these are internal to gRPC calls. For example, status codes in gRPC are different than the protocol level status codes. If we talk about what happens inside the gRPC request, which, by the way, gRPC request, it's underneath the protocol over the single TCP connection, we'll see that, I think in the, not bidirectional, but here. You'll see here that we get a catch, and what we catch is an RPC exception call that happens only when the status code is canceled. With gRPC, on top of the status code that we get on HTTP protocol level, we will have this enum that contains 16 values that are specific to gRPC itself. Because basically, we needed a way to determine what happened with our small individual gRPC request. Because you might have like 10 gRPC requests over a single TCP connection, but each individual gRPC request might fail. And you need a way of telling the client that, hey, your gRPC request has failed, your second gRPC request has failed, because in itself, the connection, the TCP connection, it's still open. And you have no way of throwing the status code from that connection yet. You will be able to send the status code at the end only when all our gRPC requests have finished, successfully or not. So we will get this status codes, aborted, not found, already exist, unavailable, and so on. And when it comes to exceptions, gRPC comes with their own of type RPC. So if you want to find out what happened on the server side, that you do not receive a response or something like that, the only thing you have to do is to catch an RPC exception and to look at that status code property. Okay, so this is the only thing that you can do. Another thing is related to request headers and response headers. And we have a small animation. So in HTTP requests at the protocol level, we know that we have headers, body, and on top of it, we have an HTTP method. It's a post, a get, a put, an option, a head, and so on. But when it comes to gRPC, those gRPC requests come inside the initial HTTP request body, and they get sent, and the gRPC request itself can be split into two chunks. One of them is made of metadata or request headers to that specific gRPC request, and the second one is the actual message that travels within, okay? So this is how gRPC sits underneath the protocol. In terms of HTTP response, we have headers, we have body, and of course we have the status code, 200, 404, and so on. 64 of them, I think. But when it comes to gRPC responses that come with the body, we have those responses, and that response can be made of different things. We can have the actual data that comes as a response, and only old gRPC responses have finished. For example, we have bi-directional, or we have server streaming. Only when the server finished streaming all the gRPC responses, we might get something back that is called trailers. These trailers are nothing more than key value pairs that get added from the server side to the gRPC context, because we basically need to have a different way of sending things that are not fit for the response body itself. So we will have a look here, and you'll see that on the server stream bit, we have this thing, metadata, entry my header, which has a key and a value, and it's simply added to the context called response trailers, and these get added. And if we look in the console for the server streaming, you'll see that here we had something at the end, found some trailer values in gRPC response, and that value is gRPC header, which is pretty much the thing that I added here, my fake header, gRPC header. So if something it's not fit for being in the body, this is where we can add it. And on the consuming part, if we want to extract those, we can simply call a method named getTrailers, which will extract the dictionary that trailers that come with the responses at the end. And if we want to get a specific value that we know we will find there, we will get the value and pass in the key. And if that key is found, we will get an actual value and a response there. Since we're short on time, I think we might have some things that we can mention. So we can tweak some things in relation to gRPC. We can set the maximum message size for it, the maximum send size. We can add our own compression algorithms. And if we want, we can intercept the things that travel around gRPC. So in here we have a concept named interceptors, where they're similar to a middleware, but they run at the gRPC level for individual gRPC requests. So we have a way of injecting ourselves in the pipeline. And on top of them, we will have the middlewares that we know of. When it comes to security, we have some things that are supported. We have two types of security that can be added. Those can be added at the channel level and at the connection level, which is higher. And everything that we support in terms of basically authentication and security related stuff, gRPC supports it too. But it doesn't support Windows NTLM. So that's something that doesn't work with HTTP2, and that's why it doesn't work with gRPC itself. So one more minute. What gRPC should do awesome? gRPC should do awesome gRPC transcoding, which is a way of transcoding, and I'm going to show you some code. You'll be able to run it and test it yourself. gRPC transcoding is a thing that allows us to run also as a RESTful API. So for example, we have an RPC method exposed here that is RPC, but we also want to expose it as a method in the browser. So we'll be able to call it from the browser too. So just by installing a simple package named gRPC JSON transcoding. So now if we open the browser, without me, I will be able to go in there and make sure, just a second. I think it should be. ABP. And what we get here is hello ABP, okay? So don't be fooled. If you run this and you look into the network, you'll see that it uses HTTP2 as a protocol. This is the request URL. And you'll see the MIME type is application JSON, okay? So from the browser to the gRPC service, you won't be able to communicate end-to-end in gRPC, but the package, gRPC transcoding, will do the translation for you. So that's it. Thank you for having me. I will be online for and available for questions. So I won't take much of your time. I'm going to answer to Q&As on the session. So thank you very much for listening to me.
Thank you so much, Irina, for sharing your knowledge with us. Okay, I think we do have some questions. You want to check?
Yes.
Listening? Okay, great.
Okay, so if we have time. Otherwise, I can answer to those on the website.
Yeah, no worries. We can check maybe 1-2 questions, and
Okay.
then we can answer from here, and then later we can answer them from the chat.
Okay, so I have one question, like randomly, I'm not gonna discriminate. I have one question from Gordon. How do you deal with retries and fault tolerance? Well, retries and fault tolerance are embedded in gRPC. That's something that I usually talk about. Retries have a way of being configured per client that calls a gRPC service, and the gRPC service will be able to retry it. We can have retry policies or hedging policy out of the box with gRPC. I have a question from Sorin. In which situation is gRPC advantageous in what types of architectures? So basically, whenever you have a service calling another service that is downstream and not public facing usually, that's a good candidate for putting gRPC in between. gRPC I'm going to say like the mainstream architecture, microservices. If you need to travel data from one side to another and you're not yet using messaging, gRPC might be a good fit. Question if the code is available anywhere. Yes, I have a repository that I can share if just a second. Where should I put this maybe? Aru, you'll be able to share a link with that in this somewhere?
Yeah, sure. But actually, you can also drop the link from chat. Are you in the event hub with us?
It should be somewhere if I can find.
No worries. You can share with me, Irina, and then later I will share with all of you guys.
I will get there. Yeah.
Yeah.
I think
we will have the.
So you can find me on GitHub, Irina Scurtu, to find the gRPC update, and you'll find this. Just lost the page. But I will be online for a while, so.
Great. All right. Well, I can see people really, they feel attached with your presentation, and because we can see from the questions. Unfortunately, we have really limited time because we have the next session upcoming. So thank you so much for Irina again for sharing.
Thank you for having me.
Very insightful talk with us, and we will see Irina hopefully for next ABP conference. Yeah.
Thank you very much.
Thank you for all of you for this session. And now you can maybe grab a coffee or something, stretch your arms, head, everywhere. And with the guys who booked for the next session, we will see you for the next one. Thank you, guys.
Bye.
Bye.